Okay, when two quantities are proportional, we can solve proportions to find an unknown quantity. A proportion is an equation stating that two ratios or rates are equal, and in a proportion, the cross products are equal. We use this property to solve for an unknown quantity in a proportion. Alright, so we have this proportion to begin with, and this is showing that these two ratios are equal. X over 12 is equal to 15 over 18. And proportions typically look kind of like equivalent fractions. It's just we're going to use a different way to solve them than thinking of them as equivalent fractions. But just be aware that that is a rather similar concept. So when this talks about the cross products, that's exactly what it sounds like. Products means to multiply, and cross because we're going diagonally across the proportion. So if you look at the things that are diagonal across the proportion from each other, you have 18 and x, and you have 12 and 15. So it says the cross products are equal. So what we get when we multiply 18 and x must be equal to what we get when we multiply 12 and 15. So this cross product here, 18 times x, is what we get from those two parts. And then this cross product here, 12 times 15, is what we get from those two parts. And this is how we will set up to solve a proportion. If you notice from here, this is just a simple equation that we can simplify what's on the right side, simplify slightly what's on the left, and then we just have one step to go to solve that. So that's how we will solve proportions. So let's take a look at example 4a. It says solve each proportion, and the first one says c over 36 is equal to 9 over 15. Now when we go to find the cross products, what I like to do is look for where the variable is first, and make sure I get this cross product first, so that the variable will always be on the left. We know we really like the variables to be on the left. So here we have 15 times c, and that cross product has to be equal to the other cross product, 9 times 36. Alright, well 15 times c is just 15c, and then 9 times 36 is 324. From here, we just have one step to solve this. We'll divide both sides by 15. We get that c is equal to 21.6. Right, for the second one, same thing. Here's the variable, so let's start with this cross product. So 4.8 times b, and then that's equal to the other cross product, 16 times 1.5. Alright, 4.8 times b is just 4.8b, and then 16 times 1.5 is 24. And then from here, to get v by itself, we'll divide by 4.8 on both sides. And we'll get that v is equal to 5. Okay, and on this last one, this looks a little bit different, because now when we look at the cross product, this isn't just a single variable. It's not just x, it's x minus 18. Well, still, the cross products will be equal. It's just how we multiply these that'll look a little different. But just like I've done in the past 3 parts where I found those cross products, I've taken whatever's in each of those parts of the proportion and just put them in parentheses to show the multiplication. And there was a reason for that. I know most of you probably could have jumped straight from this proportion on 4a straight down to 15c equals 324. Same with this one. V times 4.8 is 4.8V. 16 times 1.5 is 24. But the reason I wrote this middle step out is so that it was really easy to see when we got to this one how to do it. Because now when I write it, I don't even have to think about what I'm writing. I'm just writing the cross product. 8 times x minus 18. And then the other cross product is 24 times 15. Okay. And this may look a little funny over here, but all we need to do to simplify this is distribute the 8. So 8 times x is 8x, and 8 times minus 18 is minus 144. And on the right side, 24 times 15 is 360. Okay, now we spent a lot of time solving equations before this chapter, so we should know exactly what to do from here. So we'll add 144 to both sides. We have 8x is equal to 504. And then to get x by itself, we'll divide both sides by 8. And we get that x is equal to 63. Alright, and then there's 3 for you to try on your own. So go ahead and pause the video, work through those 3 problems, and then when you're ready to check your answers, go ahead and hit play so that you can restart the video, and you can check and see how you did on those 3. Alright, and for 4a, you should have gotten x equals 1.4. For 4b, you should have gotten t equals 10. And for 4c, m equals 73. Okay, let's look at a couple more examples. Number 5 says an architect builds a model of a building before the actual building is built. The model is 8 inches tall, and the actual building will be 22 feet tall. The model is 20 inches wide. Find the width of the actual building. Okay, so let's draw a brief picture here. We're talking about a model of a building compared to an actual building. So here's our model, and then the actual building. And we know these two have to be proportional because a model of anything is designed to have the same ratios as the actual figure. So whatever the ratio is of the height to the width in the model, it has to be the same for the actual building. So let's look at the information we have. We know the model is 8 inches tall. So here's the model, 8 inches tall. We know the actual building will be 22 feet tall. So 22 feet tall for the actual building. We also know that the model is 20 inches wide. So the width of the model is 20 inches. What we're trying to find is the width of the actual building. So we don't know the width. However, I could tell you that if these are both in inches and this one's in feet, then this one should also be in feet. And that should make sense. When you're talking about measuring the actual building, it would make sense to measure that in feet and not in inches. By the way, if your first thought here is to change our units so that everything is in inches, you could do that, but you're going to end up creating a lot more work for yourself. Because we're dealing with ratios, everything does not have to be the exact same units, because these will have a ratio all on their own, and they have the same unit. And these also will have an equivalent ratio, and they will have the same units. So the two ratios together don't have to have the same units, though. But that's exactly how we're going to set that up. If these two are proportional, then this ratio of height to width should be the same as this ratio of height to width. So if we put the height of the model over the width of the model, that should be equal to the height of the actual building over the width of the actual building. And notice when I wrote these down, I said this out loud just to keep myself straight on what goes where. So here, this is the height of the model, the width of the model. Height of the building, the width of the building. Notice everything is lined up correctly. Height and height, width and width. You have to double check this and make sure this part is correct when you set up a proportion, because if you set it up incorrectly, it will come out incorrectly. So now let's look at our cross products just like we did before. Here we have 8 times x, and then this cross product, 20 times 22. And 8 times x is 8x, and then 20 times 22 is 440. And then to get x, we'll divide both sides by 8. And we get that x is equal to 55. And since we're looking for the width of the actual building, we know that this is in feet, so this should be 55 feet. Alright, now number 6 is a rather similar problem. It still represents something that's proportional. It says a serving of 4 crackers contains 70 calories. But we're going to approach this one a little bit differently. It says to write an equation relating the number of calories, C, to the number of crackers, N. How many calories are in 7 crackers? Well, this still represents a proportional relationship, and if the question didn't say write an equation relating the number of calories to the number of crackers, we could actually solve this one with a proportion as well. However, if we have to write an equation anyway, we might as well just go back to what we did earlier on in this lesson on example 3, where we found that unit rate first. In this case, we're talking about crackers and calories. So again, think about it. It wouldn't make sense to say how many crackers are there per calorie. We want the number of calories per cracker. So start with 70 calories for 4 crackers. And then to change this to a unit rate, we want a denominator of 1 cracker. So we'll be dividing by 4. And 70 divided by 4 is 17.5 calories. So this means that there are 17.5 calories per cracker. So then to write this in an equation, this says that the calories, C, is equal to 17.5 per cracker. 17.5 calories per cracker, so times the number of crackers. So there's the equation to answer the first question. Now the second question asks us to also find how many calories are in 7 crackers. So if this is the number of crackers, it replaces the letter N in our equation. So C equals 17.5 times N, which is 7. And when we multiply 175 or 17.5 times 7, we get 122.5 calories. And this is the same number we would have gotten had we set up a proportion here. 4 crackers have 70 calories, 7 crackers have how many calories? So 4 over 70, this is what the proportion would have looked like. 4 over 70 equals 7 over x. 4 crackers, 70 calories, 7 crackers, how many calories? Crackers, calories, crackers, calories. Crackers are in the numerator, calories in the denominator. Have to make sure everything's lined up. If we found the cross products here and set them equal and solve for x, we would get 122.5. So just pay attention to whether the question is actually asking you to write an equation. If so, do it that way. If not, I would suggest setting up a proportion. It will probably be faster. Alright, And the last thing we have is two problems, again, for you to try on your own. So pause the video, work through those two problems. When you're ready to check your answers, hit play to restart the video, and you can check and see how you did. Okay, for 5A, it asks how many care packages can they make with 510 food items? And you should have gotten 17 care packages. For 6A, there were two questions. Write an equation relating the cost C to the number of DVDs D. So for that equation, you should have C equals 9.89 D. And then the question at the end asks how much would it cost for 11 DVDs at the same rate? So the cost of that should have come out to $108.79.